This time we are going to do it through like how we are going to do it for the real-time ingestion, right? So before we went to the real-time ingestion, we should also know what is basically the, how it works. So basically, when we are going to do the real-time ingestion, so there we have to use any of the streaming techniques with the help of which we are going to get those data in the continuous way. Streaming means my data is coming at the real time and it is continuous. So the difference between batch and real time, as we already discussed, is that like batch we are going to trigger it on a specific time and for a specific duration, right? It's called batch processing. So, but the streaming is going to be, it's going to be continuous. Like continuously, the data is coming, and we are processing the data simultaneously, right? So the process is actually the same. Like what we did is like we are getting the data from the source, bringing it at the raw location, and from raw to bronze, and then from bronze to silver to gold. The pipeline always remains the same. Like it works, but how it is going to work, that depends on like if we are working going for the batch ingestion, so we are going to trigger the pipeline for on a specific time, date, day, and it is going to work for for a specific period of time. Like we generally schedule its frequency. Like we are going to trigger it once a day, twice a day, 4 times a day, or hourly basis. So that is something related to batch. But my real-time ingestion is going to be, or the streaming is going to be like the data is coming in the form of stream. Stream is what? It's a collection of data which is flowing simultaneously. So what we did is like we basically create here also we are creating the micro batches, but not the batches but micro batches. So the default batch for default streaming batch is half second. Like if we are not defining anything, so automatically my batch is going to be set for half second. So how many number of records are going to be there in that micro batch, those are going to be put in a one batch, and that is going to be processed. Let's say the stream is going to get those number of records. Let's say some 100 records come in that half a second. So those are going to be stored in the raw location, and from there raw to bronze, how we are going to do it, that goes our next process of pipeline. So that will remain the same. So here basically with Databricks, it's already been given that we are going to use like multiple ways are there through which we can use it. But as I told you, if we are going for a source like basically some sort of service that we want, which is going to ingest this streaming. So for that we are having like Kafka. Kafka is basically an open source. So if you are not tied with any of the cloud providers, so we can use Kafka. And even if we are tied with any of the cloud providers, even like Kafka API can be integrated with any of the cloud services. Apart from this, like different clouds, they have got their own services. Like for AWS has got Kinesis, then GCP has got PubSub, and Azure has got this Event Hub. So there are different services which are being provided by different cloud providers. And apart from this, like we can use Kafka. So if we are not using any of the cloud providers, so definitely we can use Kafka. So again, Kafka, what is Kafka? So Kafka, I think we have discussed earlier, but just to give you a background, it's a basically again it's a distributed public subscriber messaging system is there, which is mainly used for ingesting real-time data from different sources, and so that data is available for processing. So and this is going to be run in parallel. Like so, what Kafka does is like Kafka consumes the data in the form of topics. So we have got different topics are there. So topic is, you can say it's a one form of data which is going to be there. Let's say some address is coming, some message is coming. So that we are going to create different topics. So data related to a particular topic, that will go to the same topic. In this way, we basically used to get the data, and these topics are going to be consumed by different consumers. So in Kafka, basically what we are having, we have producers and we have got consumers. So producers produce data to those topics, and the consumers are going to be consume those data from the topic itself. So in this way, basically it happens. And whatever the data that we are producing, so Kafka is basically is organized in such a way that it is fault tolerant. Like the data is not going to be lost. So we have got a lot of like data, how we are going to retain the data. So retention policies are there, retry policies are there, and for how many for how long the data is going to be stored in the Kafka topic. So those things we can set, right, as per our requirement, and the how basically companies performing based on the criticality of the data. It basically works that way. So this is how we can use the Kafka. But to process it, basically we are going to use Spark structured streaming that we are going to use for processing the data itself, right? So again, this streaming is Spark structured streaming is what this is. Again, basically it's a it's a API which is provided by the Spark itself, which allows us to make the same operations that we perform in the batch mode. The same operations we are going to apply in the streaming fashion here. So basically, how we are doing it, we are just reducing this latency. So and the data which is coming, it's coming in the incremental way. So whatever data has been processed, we are not going to process it again. So each of the the records that we are getting is going to be processed and guaranteed processed at least once. So in this way, this structured streaming works. And the default, as I mentioned earlier, also like the default format that structured streaming uses the cloud files, and within the cloud files, basically the data can come in the form of JSON, it can come in CSV, like, but mostly the data that we got as a part of stream is only in the form of JSON. But it doesn't mean that that we are always going to get the data, because sometimes the data which is come that can come from the some databases also, or different other sources can be there, which is coming in the form of micro batches. So based on that, it can be we can also take it as Parquet. But mostly in 90% of the cases, basically the data which is coming in the form of streams is of the form of JSON only, right? So this is how we generally used to do it.
So can we use this Kafka like while we use Azure?
Can you come again? I didn't get your question.
So can you use Kafka with it is like kind of streaming the data, right? Getting the data
Yeah,
in
it's
batches.
an API basically. It's a, you can say, it's a service which is basically a public it's a pub sub model. Pub sub is public publish subscribe model. So basically, some data is going to be subscribed and some is going to be published and subscribed. So every data which is coming in the form of topics, that the consumers are going to be subscribed to that topic and are going to consume it, right? This way the Kafka works.
So we can use it with GCP. We can use it with Azure. That any.
Yes, because it's an open API. It's from,
Okay.
yeah. But apart from this, like as I told you, like if I talk about different organizations are using different cloud services. So each cloud has got their services are there. Just a moment, I'm getting you.
Mhm.
Sorry. Yeah. So yeah, in this way we can use it, right? Let me share my screen then. Let me know once you are able to see my screen. You can see my screen, right?
Yes.
Okay.
Yes.
So basically, I've created a demo. Basically, this is for how we are going to get the data using Kafka using streaming pipeline, right? So basically, for when we are going to use the Kafka in real scenario, so we have to use we need to have some sort of topics that are defined. So, but here we are going. It's mainly for the demo purpose. So it's totally it's some the topic that we are specifying here is just for the purpose of demo only, right? But I'll tell you where we have to make what kind of changes that we are going to use. So we are going to ingest the data from Apache Kafka, right? Topic, which is it's just a some sort of mock data, because if we have to do it in the real scenario, then we need to have first Kafka API installed, and we have to create a link with some sort of sources from where we are going to get that data, and that is going to provide us some sort of that topic. From there we are going to use, and but for processing we are going to use the Spark structured programming. And then finally what we are doing is, once we are getting the data, we are writing the data to delta table, which is called row zone. So there is no change. Whatever data we are going to get it, same data we are getting, just adding few some of the metadata columns, like which specify, okay, this particular data has come to the system on this particular date or this particular time of so this, if you see the architecture, what we are doing is we are getting the streaming data from the source, then using Spark streaming, we are processing it and finally storing it into a delta table. So this is how we are going to do it.
What this can you please a little bit elaborate this one, the Spark streaming of
Yes. This Spark structured
structured.
streaming you are talking about, right?
Yes, yes.
Yeah. So this is the the basically this is the API that we are using as a part of Spark. So this is mainly basically used for when we have to process the real time data. For that we are going to use this Spark structured streaming. So in when we like, and for any cloud provider it doesn't going to matter. So because Spark is again is the common thing that we are using, right? So Spark is what? Spark is a distributed technology that we are using to perform our jobs parallelly, right? So because Spark works on the distributed fashion, so it works faster. That's why everywhere we are going to use, irrespective of what cloud provider we are using. It doesn't matter, right?
It's that's fine, but I'm asking the structured streaming means we are ingesting data through Kafka, and then the Spark streaming means uh,
Yeah,
what is
Spark string is basically used for processing. So basically, it is bringing the data from the taking the data from the Kafka and putting it into the raw zone, right? There we are going
okay.
to use a Spark structured streaming, because Spark structured streaming is going to take the data in the form of cloud file and processing it, right?
Mm-hmm.
So basically, if we talk about the key concepts, so Kafka, basically it's going to be the how for the how we are going to, from where the source, how we are going to bring the data. So for that we are going to use Kafka, which is a distributed event streaming platform that acts as a message broker. Then Spark streaming, it's for processing my streaming data, and data lake where I'm going to store it. And it's because it's a data lake, we have already discussed what is the difference between data lake and lake house architecture is there. Because my data lake provides this is a transactions and time travel, like whenever we want to go back to our previous data, we can use it, the time travel. And here this is one more important point, is called checkpointing. So this checkpointing is basically the storage location where my data is going to be stored. Like if something happens, like if my pipeline goes down, so I can just go to this particular checkpoint. So this checkpoint tells me, okay, this was the last point where we have stored the data. So from that point again, my processing is going to be start. So that's why we are not going to lose any data, right? This way. So this checkpointing is mechanism mainly for the fault tolerance, right? Understood?
Okay.
Okay. So basically now what we are doing is like these are simple, some libraries that we are going to have. So first is PySpark .sql, where we are importing all the functions as f, and then because my data is going to be come as in the form of JSON, so we have to specify what is going to be the structure. So structure we can define with the strict type, and within strict type what is going to be a structured field. It can be string type, integer type, timestamp, double. So these are the major types. My data is going to be fall within these 4 types. So this struct type, within struct type we can have struct field. So it's basically my parent field. Something like I have got one let's say address is going to be there. So within the address I can address field, I can have multiple fields. Like I can have like house number, then I can have my lane number, street number, then city, then state, then country, pin code. These are going to be part of my fields, and each field is going to have different data type. So like name is going to be some structure type, but my pin is going to be integer type, or other data types can be there, like at what point of time my data has been loaded. So if it is going to be some sort of some payments and all, so there it's going to be my double type, right? So this is how my libraries are going to be. Let me run this. Okay, so here you can see all the libraries are imported, and we are using this Spark version as 4. So it's the latest that we are using, right? Then next is now how we are going to configure the connections, because we have to make the connection parameters to Kafka, because Kafka have got their their server, inbuilt servers are there. What is going to be the topic name, authentication, then checkpoint location, and what is going to be my output location. So these things we have to configure. In the next cell we are going to do it. So here we are using this smoke data as true, but in real scenario, instead of this smoke data we have to use some sort of topic. So which particular topic we are going to get data. So those kind of things. And here if you see mock events per second, like how many, like it generates at least so based on the requirement, it is generating 5 events per second. So if we are going to increase it based on the because we have to check this in our source system how my data is going to be generated. So it depends, like maybe it's going to be 100 records, it's going to be 1,000 records. So based on the like if I talk about Walmart, right, or let's say Amazon, so here the events are even a second, those are going to be more than 1,000 events per second are going to be there. So there, based on the number of events, we have to configure everything, right? But now this configuration and all, mainly if I talk about the resource side, so those things we don't need to take care about, because if we are going to use serverless and auto scalabilities are there. So there, those things are going to be done by the system itself. So we don't need to take care of all those servers things and all, right? So this is what we have to do. Like if we are not going to use mock data, here we are using mock data, so this is automatically getting generated from the system itself. But if we are not going to use, so we have to specify what is going to be my Kafka boot servers there. So there I have to specify what is my Kafka server, and at what particular this is the default this is my default what we call it as, it's my default 9092 default, because every URL works on some sort of port. Yeah, so that's the default port for my Kafka. But if this is busy, like if some so we can configure it. But if nothing has been when we are creating these Kafka boot servers, we are configuring those things. So generally it's by default works on 9092. But if you want, we can utilize another one. Then we have to specify what is going to be my Kafka topic, right? And few other things which are required. But here we don't need all those things because as we are using this, for the demo purpose, right? Then the most important, again, very important, is going to be checkpoint, because this is the one from where my, if something goes wrong, or my, let's say, there is something bad happened with the pipeline, or my pipeline got failed due to some issues. So from this checkpoint location, when next time I'm going to run it, or after fixing the issue, so it will start from this particular, location. Like what was my last point? At this point, the data was successfully, saved to the location. So it will take it start from here, so that we should not miss any of the events, right? Then this is going to be my, raw path. So you can specify these things as per your, requirements. And these are some of the, like if we are using mock data, so it will give us, okay, this how many number of events per second it is giving, as it will, go. So it's basically the, the productionized one thing is there. Like if we know all these things, what is my Kafka topic, what is my checkpoint location, what is my role table, and so if we know all those things, so we just need to pass those things here itself. So it will check if we are not using, mock data, and definitely it will go to the real, real Kafka topics, right? Let me run this. Okay. Now, whatever data we are getting, first we have to get the some sort of sample data. Based on that sample data, we are going to specify what is going to be my schema, because otherwise, like if the schema is not matching with the the data that we are getting, it is going to be fail the pipeline, or maybe like that initially if you have put something, and in streaming new fields are got added, so those are not going to be done. But that way, like schema evolution, we can put it as like schema evolution to true. So automatically, if something new is going to be appended, so at least that data is not going to be eliminated, and or it's not going to be missed. It will be there in the raw location. But final table we can specify according to our requirement. So that's why we have to specify like what is going to be my data type. So here we are going to define the what is my schema is going to be there. So the events that we are going to get here is going to be in the form of like this is event ID. This is always going to be the unique identifier. So based on this, like if this is not never going to be an duplicated one event ID. So based on this, we can specify, okay, this particular event has already been happened, and user ID and what kind of event type is there, and then at what time it's going to be in the form of timestamp, what was the page URL, product ID, amount, session, device, country. So these are going to be some of the the basic fields of data that we are getting. Apart from this, like if my data is coming in the form of some other apart from this, so generally what happens is like we have got event ID, user ID, event event timestamp is there, then session ID is there. So these are some of the most common things are there. Apart from this, generally the data is coming, so data should be there in the form of some data string or so within that data we are going to get the data in JSON format, and within that format we have to specify what actually the form of the data that we are getting, right? But here we have just specified like what kind of basic things are going to be there. But in real scenario, if you see, basically we are going to have some sort of string is there. Within that string, all the data is going to be there, which generally happens to be the data string. So for that data string also, we have to specify the schema. So here we have defined these 10 events, right? So what is my structure? Event ID, string, user ID, string, event type. So we have defined all these things. If you see, initially we have specified everything, like what is going to be my struct type. Within struct type we have got struct fields are there. So it is not necessary that we have to specify in this way, but this is the most viable way of doing things. Because sometimes like if we are not going to specify it, so sometimes what happens, like at runtime if we are doing, we can do it dynamically also at runtime, how the data is. So sometimes the data is going to change, or data type, if sometimes bad data is coming, so that can change the data type. So that will move to some another because the system is going to recognize that as, okay, this is a new data type, right? So it is going to create it in the new field, which is going to be wrong, right? So that's why what we can do is, like, it is beneficial to define your schema beforehand, right? But it's not it's basically we can say it's a convention to go with this, but it's not mandatory that every time we have to maintain this. But our pipeline should work fine, run fine, without any errors. Then this should be done, right? So in real scenarios, we generally do it in the same way, right? And in real scenario, if you see, we are not going to have this much number of fields. We are going to have main fields. We are only going to have, let's say, 4 and 5, where we are going to have event ID, some user ID, some event timestamp, or one more can be there, like data string. So that data string is going to have all the data types, like all my data. So it can have multiple fields. Show you if we can find out. Boom. This is also a very simple one, but in real scenario we have got, like, right now I'm working on a stream, ingesting a stream where I'm having this JSON data is having more than 450 different fields are there. So you can imagine what is the complexity of that schema is going to be there, because within these let's say device ID types, and these are very, but we can have, let's say, longitudes, latitudes. Within longitudes, latitudes, and we have got addresses are there, and within the address again some multiple or complex data sets are there. Again, like if the data is coming from the click stream, so it can be in the form of CSV files, session ID, user ID, likewise, and financial transactions, crypto. So there are different forms of data that we can have as a part of this, right? Next, which is like how we are going to read the data from the Kafka, right? So again, here as we are using the mock data, so basically uh, how we are reading it, we are reading using spark.read stream. So wherever I am saying read stream means we are reading the data, and the format it's coming in the form of rates, and what is the rate that we have specified, like rate rows per second, how many number of rows per second. So this we have already specified as 5 earlier. So every 1 second the 5 ends are going to be loaded, right? And then we are loading this as base stream. How we are loading it? So within we are loading it the topic as user events. Then we are partitioning it. We are right now we are just partitioning it on the basis of random partition. So it's going from 0 to 2. So in this way, the partitions are going to be there. Then offset. This offset value is very useful because this also specify this offset always remains to be the unique, so that we should not miss any of the data. Then what is going to be the timestamp at which the date we have loaded that data, and this key is going to be some binary keys is going to be there, which specifies again unique there. So there are different keys are there which specify like how the data is going to be we can uniquely identify. But the main source generally remains because based on the events, these are going to be the part of that. Then within the event, what we are doing is like we are getting two JSON, and then we are creating this inbuilt. What are going to be the different within one event, what data we are going to have. So it's going to be the value is going to be like event ID. So how it is going to find out where the data we are going to get a JSON data where it is going to be EVT underscore. So it will specify, okay, this is going to be event ID, and user underscore, it's going to be something related to my user ID. Page view. So it's basically, what it is doing is like it is here, it is concatenating, but here if you see, it's an array. So basically, as I told you, there are going to be, complex schemas are going to be there that we generally use to find out. So based on that, we are going to devise these things, right? And timestamp, page URLs are there. So once we have got this, then we have to get this, the data in the form in value column, right? And then we are finally generating this data, and this will tell us like how many number of events are going to be there. This was for the for my mock data, but if we already have the our Kafka topic is there, so we are going to use like there we are going to use format as Kafka, right? So till now we are just loading the data into the Kafka topic, right? From the source, from the streaming wherever my source is there. So from source to my data is coming to the Kafka. So once this is there, so you see we are generating 5 events per second.
Mm-hmm.
Once we have got the data in the stream, now from Kafka, now we have to bring this data to our uh, raw bucket, raw label, right? First we are going to bring it to the raw, and from then the raw to bronze, bronze to silver, silver to gold. That is going to be our usual pipeline. But the main part of the streaming is just to get the data to the raw bucket. From raw to bronze, silver, and gold. That is going to be either we can have this in the same, but it is going to be like if my data is going to be like if my pipeline is going to be stopped or failed at the streaming layer, so my rest of the pipeline is also going to be failed. So keeping this thing in mind, what we generally used to do is like we keep we generally separate these two pipelines. So first is going to be from streaming to raw, and then from raw to silver, bronze, silver, and gold. This way we can just do it, right?
Mm-hmm.
So the data that we are getting from the Kafka as a value, so that is coming in the form of binary. So we have to convert it to a string, then parsing the JSON string into structured columns, and then adding some metadata columns. As I told you, like what is going to my ingestion time, what was the Kafka metadata, and then finally selecting what are the columns are going to be there at the raw layer. So here we are just parsing and transforming my data. So Kafka stream data frame is we are creating a data frame with, we are creating a new column with the value string. So whatever the value that we are getting from the Kafka, we are converting into string. Then another is the parse data, which is again we are converting into from which we are converting into event schema. So it's going to be topic, partition, offset. These were the some metadata columns over there. Apart from this, these are going to be my data columns or the business columns generally. So we have just flattened them. So pass data, event ID, user ID, event type, what was my event timestamp, URL, product amount, some set of and few audit columns like at what time my ingestion has happened and what was my source system. So here we are just putting it as a literal string, just passing a string. Okay, my source system was Kafka string, right? But in real scenario, because the data can come from different topics, so we can specify here like what are the different topics are there that, or if we just want to generalize it, so we can do it as a Kafka streaming. Okay, so now once we have got done this, so next step is just we are going to write the data to our raw layer. So before this, I just wanted to tell you a few things.
Mm-hmm.
Because we have got different modes are there.
Mm-hmm.
Within the this streaming one, we have got different modes are there. Spark streaming, like once last time I told you, like either we can when we are just reading the data from the stream, so either we can use autoloader. So how the autoloader works, autoloader generally it checks like where if a particular file is available, so it will trigger it automatically, right? Then we can use micro batch size also, as I told you, like we are going to specify 1 minute, 2 minute, based on the how the data is coming to the system. Or if my data is coming from different other data tables, but using the streaming reads and writes are there. So if we are going to use this, so we can use available now. Available now, what it triggers is like whenever the stream is available, it will automatically going to trigger until unless once the data is not available, it will automatically going to switch off it. But in case of streaming, generally, like sometimes what happens is like my data is coming during the working hours, my data is coming or to the streams continuously. But during off hours, there is no data or very less data is coming. So there is no point of running the my compute for a whole day. So this thing, let me tell you. Few times back only we find this issue. There was one streaming pipeline which was running from morning 9 to 6. It was getting huge amount of data, but after 9 generally they were getting very less amount. So for the whole for around 14, 10 to 12 to 14, 9 to 6, 9 to 6, 9 hours, right? So around for 15 hours there was no data or very less data was there. So all the resources were getting consumed and the billing was happening a lot, right? Because if I'm running a particular streaming pipeline continuously, for which during which we are not getting any data, so there is no point of running it. So what could be the possible solution? So one thing what we can do is, like, we can trigger the pipeline from 9 to 10. This was what, or we can use autoloader also, like, until unless we are getting the files or the data, it will process the data. So this way we can just so we have reduced a lot of cost into that one. Another scenario that I tell you, like, right now we are all still working on that, because there were these basically comes under optimization things, right? But when we should know all those things when we are going to build a pipeline. Until unless we are not going to put all those things, so those creates a very huge impact on the system itself. They are going to consume a lot of resources which are just wasted. We are wasting. So very efficiently and intelligently we have to take care of all those things to. So what we did, like, there is a pipeline which is like, which was a huge pipeline, but around 100 different reports were getting generated from that final table, and it was using around different 23 different tables that were getting utilized. So every 20 minutes they have scheduled that job. So every 20 minutes, and sometimes the job is taking more than 20 minutes. So that's why it was running continuously, right? So although it should not be a continuous job, but it was running continuously for 24 hours. So it was costing around $13,000 a month. So it's a huge amount, right? $13,000 a month, just single pipeline. So what we did is we just tried to find out, and we have scheduled it, every 1 hour. Instead of running every 20 minutes, we scheduled it. So you won't believe, now the billing has been reached to $3,500 a month. Just making one change, and this has not impacted. And right now we don't know, like, how that reports are getting generated, how the peoples are. So people are using creating those reports. Are they really need it every 1 hour or so? Because they were using this Power BI. So Power BI basically refreshes the reports every 1 hour, because they were using this import functions. So it was not direct queries they were not using. They were using import functions. So import functions, they have got that before 1 hour, the reports cannot be refreshed. So that's why we put it as 1 hour. But if we get to know that okay, what should be the optimal way of like what are they really running the reports every 1 hour? If they are not running, so we can even trigger it, let's say every 2 hours or every 3 hours or every 6 hours. So that again going to reduce a lot of costs. So similarly, that's why we have to take care of this thing. So, like, available now basically process all the available data and then stops whenever the data is not there, right? But serverless doesn't support continuous streaming triggers, so we have to take care of this thing. But if we are going to work on dedicated clusters, so we can use processing time trigger. So basically we can specify, okay, for every 10 seconds it will run, and it will get the data for those 10 seconds. Use once trigger, process micro batch, and then stops. And then use, if you are going to use this continuously, so it will continuously run. So this way basically there are different modes that we can fix. And again, we can specify the format, as we are going to use the delta, our target. So we are putting it as delta, right? Then again, what is going to be output mode? It should be append only, right? So whatever data is going to be there, we should take it. And complete, it means it will look for all the entire results for aggregations, and updating existing records if required. Because if we know to let, if there is within the, let's say within last 10 seconds 1,000 records come, and those 1,000 records, there were a few records which needs updations. There was some issue, then they got updated. So those kind of things need to be checked. Then checkpoint location, as I told you, this is for mainly for the fault tolerance, and trigger controls the micro batch frequency, like what at what frequency you want to trigger it, whether you want to go for continuous trigger ones, that way we can use it, right? Uh, Now let's run this. So what we are doing is we are getting the data from past stream data frame, writing into format my delta output mode is my append. So whenever a new records are going to be there, it is going to append it, and checkpoint location is my checkpoint location. And you see merge schema is true. It means if it allows for schema evolution, like if new records, some new records or new data is going to be there, so it will automatically going to accommodate that. And here we are putting the trigger as available now. So for every whatever the like till the time the data is available, it will continuously running the job, right? Pipeline will run, and then you see what is my output. Then finally, for monitoring what was my input rate, processing rate, those things we can get it by applying these, simple, like if my length of the active stream is equal to 0, it means there was no active queries were there, else it will print like my job was streaming, what was the query ID, query status, and what was the number of records that we were getting. So I have already ran it 2 times, so that's why we'll get a lot of records in this one. So once we are done, then we are going to query the raw. So here we are going to check, how many number of records are there in each batch, right? So these are 3 total records you can see. When I've initially started it, so I was having few hundred records are there, right? But now we are having total records in the raw table is almost 30 lakhs, right? So this is how the more number of records are coming to the system. So if I'm going to run this, see, login, click toward page view, these are the number of records that we are having for different event types. So as a part of these are going to be different topics can be there, like login related, click related, add to cart, page view, purchase. These many number of records for each different type of records are going to be there. And finally, we are going to check their properties, what is my table location and all. This is just Kafka topic, partition. These are the different columns. So everything is there, right? My table type is, if you want, we want to check what is my checkpoint locations. So every time you are going to run this, the number of records are going to be increased, right? This is how it works, right? Because we are not, and right now we are just running it manually, right? So as I told you, we can go and schedule it, so every 1 day, and generally for streaming it runs continuously. But here we are just here to for demo purpose, so we are not going to run it on continuous basis, because there is we have got resource constraints are there, so that is not possible. But yeah, in real scenario, these pipelines runs on continuous basis simultaneously. So Uh, Basically, as I told you here, we are having basically two things. Batch mode, defined frequencies there. In streaming, either in streaming we can have micro batches. One way is going to be like micro batch. Micro batch means it's going to be, let's say, 10 seconds micro batch, or it's going to be continuous. Continuous means default is 0.5 seconds. 0.5 seconds. So this is default actually, because it's continuous, but just a second, half a second, it doesn't make any it's a very very less time, so that's why it looks like to be like even the seconds, like in our real scenarios, we are running multiple pipelines. So some of the pipelines, they are ingesting every one minute. Some are getting up updating my branch table every 30 seconds, but the data that we are consuming, that is coming every 5 seconds or 10 seconds maximum. But we are not even for continuous like streaming pipelines, we are mainly maintaining 5 or 10 seconds micro batch window. But as I told you, there are few companies like Amazon, eBay, Walmart, where the customer base is in in billions. They have got in billions customer, more than let's say lakhs of customers. They are clicking their systems on just every second, so they have to maintain that much of frequency. Otherwise, like if they are going to do it, let's say 10 seconds, so in 10 seconds they are going to get millions of records, and then processing the millions of records again is going to be a bottleneck for them. So what they did is like they are going to reduce this micro batch size. They are doing it like when I was working for Walmart. So there we used to maintain this 0.5 second micro batch. So it works like it is working continuously. So similar way, like it all depends like how we are going to use it, how we are doing this. So this way we can do it. As I told you, like we are going to have different processing modes are going to be there. It can be processing time. We are going to specify 10 seconds, 5 seconds. So this mainly used for wherever we want to balance the cost and performance. So it all depends, as I told you. When we are saying like available now equal to true, so here it's basically it says like my data is scheduled incrementally, and it is processing incremental batch processing is going to be there, and it is going to process as much as data available at the time of streaming job is triggered. So but if you want like there are all different modes are there. If let's say I'm saying continuous equal to 1 second or 5 seconds. So this is if I talk about real time modes are going to be there. So this is comes under continuous one, and there are few pipelines which we were call it as the real time modes. So where we are going to set the real time equal to, let's say 2 minutes or 3 minutes or 5 minutes. So this comes under which we call them as low latency operational workloads, right? So this way, basically, this indicates like the length of the micro batch. So whether we are going to use it for 5 minutes or 2 minutes. So that depends actually, right? So this way we can also process them. Okay. So any questions, any queries so far that whatever we have discussed so far?
No. So I wanted to know, apart from this, so who will does the developer will maintain those things, and then
Yeah.
uh,
This is the task of the developer only, like to maintain to create these data pipelines and maintain them, right? This is the task of the
uh,
developer.
I'm feeling like there are so much in there. It's the one person going to handle this, or is a team going to handle this? Wow,
Yeah.
how
It's
will
it's it's it's, it's depends. Like if we are talking about a it depends. Like if we are doing it like using the DLT pipeline and all, so this is not a big task, right? Uh, a single person
Mhm.
can do it, right? But if we are developing it as a framework, right? So framework means like we can like right now it's only for a single source when my data is coming from a single source and it is specific to one. So generally we don't go for this framework. But if we know that okay 10 different data sources we can accommodate in a single framework, so why we are going to replicate the same code for different pipelines? So what we are going to do is we are going to build the generic data pipeline by building a framework, and then we are going to pass this as in the form of configs. So when we are just specifying the configuration, automatically it will trigger the required pipeline as it is. So right now, if I talk about myself, so I'm building different frameworks to
Mhm.
accommodate so in future if so now the companies mainly they try to build the framework so that it should be it can accommodate new sources or different sources in the future itself. The only thing is like we don't need to modify the code every time. The only thing is like it should be config driven. Like only need to make the changes to the configuration or add new configurations to the configuration file, and it automatically going to trigger the new pipeline. This is how we generally doing it. But that requires lot more efforts to build the framework. So but if it's just the DLT pipeline, but DLT pipeline is mainly for wherever we have to deal with both, we have to within the same, pipeline, we can go for batch and streaming ones. So, and the data source are not going to be, data is not going to be too much, too complex, or it is not going to uh, add new, sources. So there we generally go for the DLT pipelines. Like if it is going to be some sort of specific, tasks are going to be there. But if generality is going to be there, some general things are there, and then we have to build, then we should go with the framework itself. So there we need some sort of team itself. Right? But yeah, as I told you, like until unless you are not going to practice these things, right? Those are not
Mhm.
going to be, work for you. I told you earlier in the, initially, because this is all mathematics, right? It's all practice required. So
Yeah.
until unless you are just studying it, maybe day two or week, you will remember this, but this will not going to work as the the things are changing. But you don't worry about the code itself. As I told you, for coding, if you are when we are using this Databricks itself, so this Genie is going to help, and maybe not in Genie. Most of the companies are now they are going to adopt the uh, AI. So
Mhm.
coding is not a big deal. The only thing is like you should know, but how we are going to what exactly we have to do, right? So
Mhm.
these things you will know when you understand these concepts, right? So first you
Mhm.
have to understand these concepts and do some practice. Then the things will be in your favor, right?
Yeah.
Because
Okay.
if you are just studying and you are not doing any practice, so maybe you got understand the you understand the concepts, you know how the pipeline works. But when it comes to for the interview, so to crack the interview, you should know the insides of the pipeline, how it works, why it is failing. So you will get to know all those things only when you are working and running. So if you are going to build a pipeline, I will share this code, but what I want is like first you try to build a simple streaming pipeline from the scratch itself, and ask the uh, you know use Genie for this, and then run it. When you are running it, you will get a lot of errors. Even if the code is going to be given by the Genie itself, you will not be able to run it in just a one go. So try to understand those things. Why you are getting that error? Wow, what is that error? How we are going to fix that? When you are going to do in this way, and definitely the things will be in your favor. You will understand, because just I'm telling you the things, you are going in that way, you will be able to understand the things, but you will not be able to adapt the things. To adapt, you have to perform the experiments, right?
Okay.
Yeah. Okay. So should we stop it here today?
Yeah.
Okay, fine. So today I'm not going to share this, but I want you to just go through it, right,
Mm-hmm.
and try to build a pipeline. First try the the batch one, then come to the streaming one, right?
Okay.
Yeah. Anything? Any questions? Any queries? Please let me know.
Mm-hmm. No, you said you are going to share this one, right?
I'll share it. But what I was asking is like if you can do it by your own self, because code
Yeah,
is not a big deal. Yeah, code
I
is not
can
a big
use
deal.
this as a yeah, I can use this as a reference, and I'll try to
Yeah,
create it
try
on.
to do it by your. If you are not, then I can share that code. Code is not a big deal, because right now you can use AI. Even your Genie is a very good one. Even if you don't have to use any of the other AIs, because now the Genie, they have got very good. Like in background, they have very good agents, and not a single agent. They are having integration with multiple agents. Like Claude is, Codex is there. They are all working for this. They have got the integration with Databricks, and even Databricks, they have got their own. They have built their own uh, agents. And also
Okay.
go through this Spark streaming documents also, because as I given you last time also, like Databricks is having very mm, the documentation at Databricks is quite good actually. I mean, I study from there itself, right? When I when I have to find something, because nobody can remember everything. You can go here and look for Spark structure. Yeah. So this is how it works. So these we are going to have different triggers are there. So that information you can get from the streaming documentation. I think here you will get all this information. Okay, yeah. Read from the stream. So autoloaders are going to be there, data tables, micro batches. So these things I've already explained to you. So similar ways you can get all those checkpoints, different. Hello, hello. Yeah, one thing I just forgot. Yeah, when I don't know. So these are the processing that we generally do. Whether it can be just wait a minute.
Mm-hmm.
Hello, ground floor. Ground floor. Yeah. So, yeah, stateless queries process raw without retaining the state. So, generally, and stateful basically may maintain the intermediate states. So, this is again very important. And one more thing I forgot to tell you, that is watermarks. So, this watermarking is basically used for, let's say, if we got, the processing, when we are doing the processing, let's say, and we are processing every, let's say, 2 minutes. So within 2 minutes, whatever the data we should get, if we lost that data, like the data came later in the streaming, so we can also use this later arrival data using this watermark. So we can define a window, like say 30 minutes. So it will within that 30 minutes, if the data is going to be that data is coming to the system and will be processed. If it is coming arrive late, other than apart from that 30 minutes, so what we will do is, like, then in that case we are going to put that data into some other table, and at later point of time we are going to process it, so that we should not miss any data, right? So this concept is also used here. So I just forgot this thing, right? So you can just go through all those these things, monitor and all we have already discussed, but yeah, what are the different order we have already discussed, but yeah, these things you can just go through, because these are very important part of this structured streaming concepts are there, that how we are going to use them, how we generally make them. So a lot of things we have already discussed, right? Maybe these we have already discussed: in trigger intervals, checkpoints, output modes, stateless. Yeah, so we have discussed almost everything, right? So just go through it, and if you find any issues, just let me know. And you see, it was updated on June 10th. So we generally got the updated information, because right now Databricks is they are updating the things within months itself, right? So they are coming up very fast releases. So it's not like previously we used to have some sort of updates in 6 months. But nowadays they are doing it weekly updates, some of the applications. So that's why it's quite good, what I feel, right? Okay. Anything else? Anything you want to discuss?
No, I'll, I'll try and I'll let you know.
Yeah, because as I told you, if you are just delaying it, so you're definitely going to forget all the concepts, right? Because uh, even though it is not that much tough, but if you are not practicing, the things becomes tougher, right?
Yeah, correct. Yeah.
Okay, then I think we can stop it here,
Mm-hmm.
and let's connect tomorrow, right? We'll
Yeah.
we'll
Okay.
discuss. We'll this tomorrow. We'll I'll try to discuss few of the optimizations. Some of the optimizations I've already discussed, but I'll try to discuss few of the optimizations from the Databricks perspective, right? Those are quite important, right?
Okay. Okay.
Okay, fine.
Okay. Thank you.
Thank you. And can we
Yeah.
can we keep the class at this time only? Because I think morning it's not working. Sometimes, like even today, I was late. Even
So,
actually I wake up early morning at 5 o'clock, and then after 30 minutes I just again went to bed, and then I wake up at 7.
here now